Alright, in this video we're going to look at Chapter 6, Section 1, Day 1, Angle Between Lines. So recall that all non-vertical linear relationships are described by the equation y equals mx plus b. M, obviously the slope, b is the y-intercept. We talked before saying that the point-slope form is the better one to use in most cases. We're just talking about slope-intercept here to remind us of what the slope and the intercept are, how they relate to what we're doing here. So every non-horizontal line has to cross the x-axis. If it's horizontal, it doesn't have to cross the x-axis. But every non-horizontal line has to cross the x-axis, and therefore it's going to make an angle with the x-axis. We're going to use that angle to define something called the inclination. So what's the incline of the line that we just made? So the inclination of a non-horizontal line is the positive angle, theta, that is less than pi, measured counterclockwise from the x-axis to the line. So we're always going to go counterclockwise when we're measuring our inclination. So here's a couple of examples of what we're going to be looking at. Obviously, horizontal line, theta is equal to 0. There's no inclination here because we're not crossing the x-axis. A vertical line, always going to have an inclination of pi over 2. If we have an acute angle, it looks like it's going to have a positive slope, and we're going to actually relate inclination to slope here in a second. But notice how we're measuring on both of these, actually all three of these, from the counterclockwise direction. So we're making positive angles just like we did on the unit circle. If we have an obtuse angle, we're actually going to end up having a negative slope on our line. So the relationship between the inclination of the line and the slope is going to be the tangent of the angle equals the slope. So slope equals tangent theta. That's the relationship between the inclination of the line and the slope of the line. So let's look at an example where we have to find the inclination. So find the inclination of the line 2x plus 3y equals 6. Now, we just saw that the inclination is going to have this relationship. So theta is our inclination. Tangent of theta equals the slope, so we need to think about the slope here. If we put this in slope-intercept form, we get y equals negative 2/3 x plus 2. So we know the slope is going to be negative 2/3. So if we take negative 2/3, plug it in here into our equation, we can say negative 2/3 is equal to tangent of theta. Now, I don't care about the tangent of theta. I want theta. I want to know what the inclination is. So theta is going to be equal to the arctangent of negative 2/3. So theta, if we're in radians, is going to be about 2.554. Or if you're in degrees, 146.3 degrees. But obviously, this is going to be the better answer because it's in radians. So this idea of inclination is going to allow us to find the angle between two lines. So to define what we mean here first, because there's going to be multiple angles there. When we have two lines in a plane that are not parallel nor perpendicular, they're going to form two pairs of opposite angles. The acute pair of the angles is going to be considered the angle between the two lines. So in the picture you can see the angle between the two lines is this theta right here. You could also call it this theta right here. I think they just kind of ran out of room in the picture. So if we look through this and play around with this picture, we can come up with this relationship between the angle between two lines. So if we look, we have this little angle right here is theta 2, this is theta 1, and this is just theta. Theta being our angle between two lines. If we look at this angle right here, we know that that's going to be 180 degrees minus theta 2, because we have a straight angle right here. We know this thing right here is also theta. So we know the relationship between theta 1, 100 minus theta 2, and theta is that we add them together to get the 180 degrees in this triangle. So 180 is going to be theta plus theta 1 plus 180 minus theta 2. So if we solve this for theta, just plain old theta, we would subtract 180 from each side. We can add theta 2 and then subtract theta 1. So theta 2 minus theta 1 is equal to theta. We get this relationship right here. Now, if we think about how we're going to measure these angles, it's going to be tangent. So the tangent of theta is going to be equal to the tangent of theta 2 minus theta 1, which, based on our sum and difference formulas from before, is going to be equal to tangent of theta 2 minus tangent of theta 1 all over 1 plus tangent of theta 1 times tangent of theta 2. Now, if we think about our relationship between theta and slope, slope is going to be equal to the tangent of the theta. So tangent theta 2 is really slope of the line 2. Tangent of theta 1 is really equal to slope of line 1. And then again, tangent of theta 1 and 2 are going to be the slopes of line 1 and 2. So there we go there. So the two non-perpendicular lines having slopes m1 and m2, the angle between those two lines is going to be right here. Now all this stuff up here you don't need to know, but all of this is where this relationship came from. So we're going to have one more example and then we'll call it quits on this video. So find the angle between the lines 2x minus y minus 4 equals 0 and 3x plus 4y minus 12 equals 0. So we'll call this first one line 1. We'll call this second one line 2. According to our formula, we're going to need the slopes of those lines. So the slope of line 1, so subtract the 2 over, divide by negative 1, so the slope is going to be 2 for our first line. And if we look at slope of line 2, subtract the 3, divide by 4, we're going to get negative 3/4 for the slope on that one. So to find the angle between those two lines, we're going to say that the tangent of theta is going to be equal to the absolute value of m2, so negative 3/4, minus m1, so minus 2, divided by 1 plus m1, which is 2, times m2, which is negative 3/4. So simplifying that a little bit, we're going to get tangent of theta is equal to 11 halves. Kind of skipping a few steps there, but 11 halves if you work all that stuff out. So we need to find what theta is. So we're going to say that theta is going to be equal to the arctangent of 11 halves, which is going to be equal to about 1.391 radians. Or if we're talking about degrees, that's about 79.7 degrees. So that's going to do it for this video. We will see you in the next one.